We are very lucky to have Louis Rosenberg with us. He is a very, I've got to get my glasses on, very talented entrepreneur and innovator. He researches augmented reality, virtual reality, artificial intelligence. He was the Cochette Endowed Professor of Educational Technology at California Polytechnic State University. He founded the Immersion Corporation and Unanimous AI, where he is currently the CEO. I thought you'd be interested to know he's also written a screenplay in 2009, a romantic comedy called Lab Rats. So there you go, a very wide-ranging guy. He developed artificial swarm intelligence, which is intended to amplify collective intelligence of networked human groups, and he's going to talk to us today about collective intelligence. Please welcome Louis Rosenberg.
Hi, I'm Louis Rosenberg, CEO and Chief Scientist of Unanimous AI, and today I'm going to talk about collective superintelligence, keeping humans in the AI loop. And I want to start off just talking about superintelligence in general, and specifically talking about artificial superintelligence, or ASI, also referred to as AGI, artificial general intelligence. There's a little bit of difference between the two definitions, but in general, what we're really talking about is AI systems that can outperform the smartest humans across a vast range of cognitive tasks, from analysis and problem solving to planning, reasoning, and creativity. And so the first thing I want to say about this, and it's gotten a lot of attention the last couple of years, is that if this happens, it would significantly change society. I mean, people know that, but they really don't think about a reality where we humans all know that there's an AI available to us that's better at us than us for reasoning, for creativity, for planning. That would really change how we function, how organizations function. And the first thing I really want to ask is, well, is that even plausible? And if you ask AI researchers, and people have, the most recent large-scale survey shows that 60% of AI researchers believe this will happen. Artificial superintelligence is coming. The debate is really on when. How quickly is this going to arrive? And so when will it happen? Well, nobody knows, but we can look at what people are saying. We can look at some of the highest profile voices, like Sam Altman, CEO of OpenAI, Elon Musk, CEO of xAI, and a bunch of other things. Both have said recently, within a decade. Do their voices count? Well, they both raised about $5 or $6 billion each to build next generation platforms to make this happen. And they're on a mission to make this happen within a decade. So it's worth thinking about what they're saying. Then there's Denis Hassabis, who just won the Nobel Prize, runs AI for all of Google now. He just recently said, within a few years to a decade. So he pulls it in a little bit, and he's a very serious guy, one of the I guess, the people who I would say it's worth listening to the most when it comes to a forecast. Then there's Jensen Huang, CEO of NVIDIA. He just said within 5 years. And NVIDIA now, obviously, the largest company in the world by value, makes all of the chips used in most large-scale AI systems. His perspective maybe is a little self-serving, but also very worth considering. There's Dario Amodei, CEO of Anthropic. He just said by 2026 or 2027. So he's looking just 2 or 3 years out. So serious people who know this space are saying closer and closer dates. My view is that it doesn't exactly matter when we reach this formal definition that an AI can outperform the smartest humans on everything that we can do, there's really no doubt at this point that within the very near term, AI will rival most humans on many cognitive tasks that are important. And a lot of that will happen this decade. And so I look at it as we're already entering this age of superintelligence. And the only unknown is how quickly will it be fully realized. And so if we look at superintelligence in current architectures, we always start with this big database of knowledge. And now big means pretty much all of humans' documents and artifacts and videos and images. And as we all know, we train these large language models on these large databases of information that has now recently become multimodal large language models that are training not just on text documents, but video and audio and anything it can consume. And then over just the last 18 months or so, these systems have now included additional reasoning capabilities, sometimes called chain of thought, where they'll spend more time thinking about a problem, iterating on a problem, and are getting better and better. And as when these systems first came out, they were limited to the information that they were trained upon, but that's been solved in the last couple of years with retrieval mechanisms, often called RAG, where these AI systems can go out and retrieve information to supplement their embedded knowledge, and now we can solve lots of important problems, and that's getting increasingly better. And so if we look just a few years out, what is this going to mean to large-scale organizations? Well, it's going to mean that we're going to rival human abilities and even achieve superhuman abilities in certain categories on a bunch of important tasks, things like customer support. Within the next few years, we'll have superhuman abilities on customer support, where it's not just that we can replace humans, we can exceed the abilities of humans, superhuman abilities for executive assistants in large categories of tasks, superhuman abilities for content generation, whether it's text content or visual content or scientific papers, exceeding, again, not yet exceeding the smartest humans or all humans, but exceeding many humans. Data analysis, exceeding the ability of data scientists to extract insights, and software development, exceeding the ability of of programmers. Again, not exceeding all programmers, but exceeding large numbers of people in large range of tasks. So this is happening quickly, and we can expect this very soon. But if we think about this a little bit further out, we say, well, what about, will artificial superintelligence solve all the complex problems across large organizations, which is an issue that lots of people here think about. And if we look at this architecture, my view is firmly no. These systems lack sufficient knowledge and understanding of the organization. Why do they lack that? Because they have access to this large database, but they're missing one of the most important databases, which I refer to as the human database. An organization is not just the information that's stored, but it's all of the people in that organization and the information that's in their heads. And we're talking about their knowledge, their wisdom, their skills, their expertise, their insights, their intuition. This is really the value of an organization more than the database information. And if we want to harness that by bringing that into the system, that's when we start talking about collective superintelligence. And so when we start building a collective superintelligence that connects people, again, I'm not talking about taking people and giving them surveys and extracting data that we're going to train on. I'm talking about connecting people into these systems. When we do that, we can now start to push towards systems that will give true superhuman abilities across organizations, where we can optimize products and services at levels that have not been possible before, optimize strategic decision-making at superhuman levels, optimize business forecasting at superhuman levels, optimize collaboration and communication across large organizations at superhuman levels, and optimize organizational efficiency at superhuman levels. And We get one additional benefit if we create a system like that, which is that this human database also contains human values, human morals, human ethics, and human sensibilities. And this was really the reason why over a decade ago, I really focused my career on building collective superintelligence as an alternative to pure digital superintelligence, because we need to be able to bring human sensibilities and human values and human morals into this system in real time if we're going to rely on these systems to make decisions for us and to optimize products and services for us. And so the big question then is, how do we build collective superintelligence? And that's what I asked myself over a decade ago. And my approach was to do something that a lot of researchers do in a lot of fields, which is, hey, let's look to Mother Nature for guidance. What does Mother Nature teach us about this? And it turns out that Mother Nature has a name for amplifying the intelligence of large organizations. It's called swarm intelligence. And swarm intelligence is the reason why birds flock and fish school and bees swarm. They can make decisions that are significantly smarter together than they could do on their own. And so today, just as a quick outline of how I'll talk about how we build collective superintelligence, I'm going to start with swarm intelligence, which is, again, nature's method for amplifying the intelligence of large groups and enabling really smart decisions. And as a hint, it's not about aggregating big data sets. It's about forming real-time deliberative systems. Then I'll talk about artificial swarm intelligence, which is enabling swarm intelligence among large networked human groups in real time. I'll review the first generation technology that I was involved in building, and it goes back to 2014, called Swarm AI. And I'll talk about a bunch of research studies that show its value and things that we've done with it. And then I'll talk about the second generation technology called conversational swarm intelligence, which we just started publishing papers about in 2023. And conversational swarm intelligence allows very large groups to amplify their intelligence through real-time conversation. And by large groups, I mean conversations among 50 people, 500 people, potentially 5,000 people, or even larger than that. And I'll talk about how that works. Then I'll talk about ThinkScape, which is a new software platform that actually enables real-time conversational deliberations at scale with amplified intelligence. And talk about some recent research studies that we performed in collaboration with Carnegie Mellon and some other universities that show that these large-scale conversations actually work as a way to make groups smarter. And then I'll talk about how it all comes together into collective superintelligence to give some really interesting use cases in enterprise collaboration, consumer insights, market research, even civic engagement, and big science. So with all that said, why collective superintelligence? And the reason that I like to give is really controversial in the world of AI, which is that people are smart. And I know that sounds like a joke, but I go to a lot of AI conferences and give talks, and almost nobody is starting their AI development effort from the premise that people are really smart. They're starting from the premise of how can we automate and replace people in a lot of tasks. If we start from the premise that, hey, people are really smart, people have in their heads unbelievable amounts of knowledge and wisdom and insight and experience and intuition, and then we ask the question, how do we harness and amplify the intelligence of large groups? We end up going in a different direction. And when I say harness and amplify the intelligence of large groups, I'm talking about making smarter decisions, solving harder problems, generating more accurate group insights. And my personal driving philosophy towards pushing into this space is that people are not just data points for mathematical aggregation. And I say that because a lot of this work comes out of the field of collective intelligence, which is really based a lot on collecting data from individuals through polls and surveys, and then aggregating that data and doing something called wisdom of crowds, which groups get smarter when you aggregate their data, but they don't get that much smarter. And if you look to nature, nature says, hey, that's not the way to do this. We shouldn't be just aggregating data, we should be connecting groups together. And so my view is that people are not data points, people are data processors. People are data processors that can think and deliberate together, and we should build those systems and connect them to AI, and that's what brings us to swarm intelligence and allows us to learn from nature. And so nature evolved this optimized method of amplifying the intelligence of groups. What nature doesn't do is nature doesn't take votes or polls or surveys. There's no survey monkey in nature. Nature doesn't analyze big historical data sets to find insights. Nature forms systems, real-time systems with feedback loops that enable the groups to deliberate and converge on optimal solutions. And by deliberate, when I'm talking about something like a fish school or a bee swarm, we're really talking about a tug of war among perspectives that finds the solutions the groups can agree upon with maximum conviction. And when groups converge that way, they almost always converge on the best solution or close to the best solution. And biologists have shown that large groups of organisms, like bees and fish and birds, make much smarter decisions together than alone. And so they call it swarm intelligence. And the interesting question for all of us and for me is, well, can humans form a swarm intelligence? And that brings me to the first generation technology called artificial swarm intelligence, or swarm AI, that's been around for a decade and done really interesting things. And it was developed way back at my company, Unanimous AI, with collaboration with from universities, where what we did was we looked at biological swarms and we said, how do they amplify intelligence? And then we looked at, can we create the algorithms and interfaces to allow humans to form similar swarms? And so this is a visual example of an artificial swarm. Each of the little magnets you see is controlled by a person in real time. They could be connected from anywhere in the world, and they're using their mouse or their touch screen, and they're not taking a vote. What they're doing is they're moving their magnet to apply influence on the system, and the closer their magnet is, the stronger their influence, and it's actually modeled on how bee swarms make some remarkable decisions. And the way this system works, called swarm, is a question appears on everybody's screen at the same time. In this case, the question was, what's the probability that interest rates will rise over the next 4 years? And so the question appears and everybody behaves, and then there's AI algorithms that are watching everybody's behavior to assess their confidence and conviction. And so at a high level, swarm AI is a real-time system with participants acting and reacting and interacting, revealing the strength of their conviction to underlying AI algorithms that guide the system to solutions. And the really cool thing is that what the people see is really simple. It doesn't require any instruction. Just say, use your mouse, control the magnet, let's answer a question. What the AI sees is a cloud of behavioral data that reveals the confidence and conviction of the participants in real time. And the other really cool thing is that it's a feedback loop. And so question appears, everybody behaves, the AI looks at their behaviors, decides how the swarm should move, and as soon as the swarm moves, everybody changes their behavior. And so the AI influences the people influence the AI, and they converge together on solutions. And as I'll show through some studies, it gives really remarkable results. And before I get into the academic studies, let me give one fun example. And so one of the things that we do at Unanimous AI is we take challenges from journalists because they're always saying, oh, you can't really make groups of people smarter. And we say, well, give us a challenge. And during a number of years ago, we were challenged by CBS Interactive to predict the Kentucky Derby. And so they said, predict the Kentucky Derby, but not just the winner, predict the first 4 horses in order. Now, in horse racing, that's called the superfecta. That particular year, the odds were 540 to 1. It's really one of the hardest bets in sports. And the traditional way to do this with AI would be, oh, let's collect a whole bunch of data about horse racing and put it in a database, and let's get data about the horses that are running and the weather, and let's try to make a prediction. You can do that. Nobody's ever predicted the Kentucky Derby that way. What we did was completely different because we care about the human database. So we just got 20 horse racing enthusiasts, not professionals, but people who really know horse racing. And we said, let's connect those people together and have them make forecasts. And so the process, again, collective superintelligence, is take real people, connect them together with these AI algorithms, and build an amplified intelligence called an artificial swarm intelligence, or swarm AI. And so this is what it looked like. They came into this software called Swarm, and here they're negotiating, AI is watching their behaviors and guiding, and they converge on Nyquist. as the winner. Now, we did this for second place, third place, fourth place, and then we gave the predictions. Oh, I should say that the AI sees this cloud of behavior. We gave the forecast to the reporter who wrote an article, and she actually went to the Kentucky Derby and tweeted out a ticket. And so this put a lot of pressure on us, because now there's this article with our prediction. She tweets out a ticket where she bet on these 4 horses. And the reason this is a fun story is that we gave her good prediction. So she turned a $20 bet into $11,000, and I was fortunate enough to place a $20 bet, so I won $11,000. The reporter won $20,000. There was a bunch of her readers sent her notes saying they won money. One reader won $50,000. So it's a fun story. But the more interesting thing about it is that if you go back and you look at these 20 people, not a single one of them got all 4 horses correct on their own. And had they just taken a vote, they would have gotten 2 out of the 4 horses correct. But when they worked together as a deliberative system, a negotiation, they converged on solutions that were better. Now, this is just one example. It's not a rigorous proof. So we partnered with a bunch of universities to conduct lots of studies over the last decade, and I'll just go through a couple of them. And so we did a study with Oxford University where we had groups predict, groups of 40 sports fans predict 50 soccer games, 50 consecutive soccer games. So we get statistically significant results, and we had them do it alone. We had them aggregate as a wisdom of crowd, and we had them do it as a swarm. As individuals, they were 55% accurate. As a crowd, they went up to 58% accurate. Wisdom of crowd works, but when they worked together as a real-time dynamic swarm, they were 72% accurate. And I should say this, all these papers are on our website, unanimous.ai. You can see the papers. We did a study with MIT where we connected groups of financial traders. I think it was 15 financial traders, and they predicted the price of gold, the price of oil, and the S&P 500 every week for 20 consecutive weeks. They either did it alone, or they took a vote, or they did it as a swarm. And when they worked together as a swarm, we amplified their intelligence by 26%. We did a study with Stanford Medical School, funded by NSF, where we had groups of doctors. And these were actually small groups of doctors, just 5 doctors. And they were radiologists, and x-rays would pop up on their screen. And they were asked to predict the probability that the patient had pneumonia. And they either did it alone, or they did it as a vote, or they did it as a swarm. And when they worked together as a swarm, we reduced their diagnostic errors by 33%. So Mother Nature's right. And this technology of swarm AI works. It allows groups to reach optimized decisions quickly and decisively as a real-time deliberative system. People are interacting as data processors in real time, not as data points. But there's a significant limitation, which is this really only works for simple problems like numerical forecasts, multiple choice selections. It's not as flexible as we'd like. And this is not how humans deliberate most efficiently. We humans deliberate most efficiently conversationally. Conversational deliberation is the most important collaboration method for evaluating problems and generating ideas and surfacing insights and finding solutions to harness the combined knowledge, wisdom, and insights of a group. And so for a long time, our goal has been, well, how can we enable the power of swarm with large-scale conversations among groups? Like we want to have hundreds of people hold conversations and converge. Turns out there's a problem. The problem is that conversations are really only viable for small groups. Lots of research for over a century have shown that kind of the ideal size of a group having a deliberation is about 4 to 7 people. You get a good amount of airtime per person, a small amount of wait time for people to respond. But as the group gets bigger, your airtime goes down, your wait time goes up, and it ceases to be a conversation. Above 12 people, it's really just a series of speeches, and above 20 people, it's just chaos, right? So we have this problem. What if you have a large group? What if you have 40 people or 400 people or 4,000 people, and you want to harness their intelligence through a large-scale conversation? How do you hold a thoughtful and productive conversation? Can you bring them into Zoom? No. You could try to bring 20 people or 40 people in. It's not going to be a conversation. There's really no tools that would allow real-time deliberative conversation. And this is a problem because the average Fortune 1000 company has over 30,000 employees, and yet only a handful of people can deliberate conversationally at a time. There's just a fundamental human limitation. It's also a barrier for collective superintelligence if we really want to leverage the knowledge and wisdom of groups, of large groups. And so we managed to solve this with, again, help from Mother Nature. And this actually brings us back to fish schools. Fish schools were a really amazing inspiration for how to solve this problem. So I like to think of a fish school as an organization. It's a large organization with thousands of members, and nobody's in charge. And yet, they can make remarkable decisions. I mean, a fish school is navigating the ocean, making all of their life's decisions of where they go to find food, to escape predators. All of their decisions are made this way, and they make them so well, biologists refer to them as a superorganism. That they are good at decision making. So how do they do this? Well, the first thing to know about fish is they have a special organ on the side of their bodies called a lateral line. And a lateral line detects pressure and vibrations in the water around them. And so it allows them to detect the speed and direction of the neighboring fish, which is basically the intentions of the neighboring fish. By detecting each other's intentions, they have this little tug of war, this little negotiation in small groups. All these neighboring groups are negotiating. And the cool thing about fish is that all the neighboring groups overlap. And with all the neighboring groups overlapping, it means information can propagate through the full system, and they can make smart, rapid decisions in real time. So let's look at this in practice. So here's a fish school. How does this school make smart decisions? Well, let's give them a hard, complex problem. Again, here's this organization, and here's a problem. And now, this is a really interesting problem for an organization, because first of all of the individuals have limited information. There's small pockets of fish that are aware of predators, but most of the fish are unaware of any predators, and some fish are only aware of one predator. And so no individual in this organization has enough information to make an optimal decision. That's like every organization. Most individuals have maybe no information. And so if we look at this and dig in a little bit, we say, okay, there's 3 pockets of fish that are aware of a predator. The fish in the upper left, they see a predator, they have their negotiation, they want to move down and to the right. The fish in the lower left, and see a predator, they want to move up and to the right. And then the fish in the upper right see a predator, they want to move down and to the left. Okay, so that makes sense, that's simple. It doesn't solve the problem. It doesn't create collective intelligence, collective superintelligence. The magic is that all these groups overlap. And so the information propagates through the system and actually results in a decision. And the fish will make this good decision, and it's rapid and effective decisions. So, can we learn from this and use this among large human groups? Well, let's say we have a human group of 250 people. Real-time conversational deliberation is impossible among a group of this size, but Mother Nature would say, hey, let's break this group up into small groups that are sized for optimal deliberation, 4 to 7 people. So we could take 250 people, break them up into 50 groups of 5 people. And that's a good first step, and each of these groups will have a good conversation, but it's not a collective intelligence, it's not a superintelligence, it's not one conversation. So Mother Nature would say, oh, well, just make the groups overlap. Okay, we could do that. We could have all these groups conversationally overlap, and we'll create a collective superintelligence, and we try this, and this fails. This fails because humans are not fish. And in fact, people cannot be in more than one conversation at a time. And there's actually a name for this. It's called the cocktail party problem. So if you're at a cocktail party, you can be in one conversation, and it's great. And if you overhear something next to you and you start paying attention to that conversation, you lose track of the conversation you're in. We can't be in 2 conversations at once. And in fact, our brain has evolved to do the opposite. We're really good at tuning out all those other conversations. And so this problem has been unsolved. We can't have large-scale conversations. But we solved it, and we solved it by using an artificial agent. We created this artificial agent called a conversational surrogate agent, and we put one in every one of these groups. And then we task this conversational surrogate agent with some rather simple tasks. This agent observes the conversation in its local group, extracts insights from the conversation in ideas and insights and reasons, extracts these insights, and then it passes those insights on to agents in other rooms who then express them conversationally in the room. And so if I'm in one of these rooms, I'm having a conversation with 4 or 5 other people, and there's an artificial agent, and that agent will join the conversation. It's not going to make things up. It's not going to get data from some other database. It's just expressing insights that another agent passed to it from another room, and it weaves the whole conversation together into a single large-scale conversation that we call conversational swarm intelligence, and it enables groups of potentially any size to hold large-scale conversations, and it allows us to extract knowledge and insights in real time in this distributed way and database it while the conversation is happening. And so we built systems that do this going back about 2 years now, allowing groups to break up into small groups and pass information. And we can use this technique to have large groups of 40, 400, 4,000 people, potentially even 4 million people hold conversations. The largest we've done is 500 people, mostly because it's hard to get large willing groups to hold real-time conversations. But what can we do with this when they have conversations? Well, we've had large groups hold brainstorms together. 400 people hold a brainstorm where they're building on the ideas of other people from other groups, and the ideas that are most interesting emerge to the top. We've had large groups debate complex issues, basically having arguments across 400 people, and ideas and arguments are passing around the system, sharing knowledge. It's most interesting when these large groups have diverse skill sets and diverse knowledge. So now knowledge and perspectives are passing through the system. We've done groups where there's people who are marketing people and sales people and business people, and they have different perspectives that are all passing through this network, all in real time. We've had large groups prioritize objectives, where there's a set of objectives, and they want to converge on a set of priorities that they can all agree upon. And it works really well, and the groups come around with a lot of buy-in for these answers. We've had groups estimate requirements, how long is something going to take, how much something is something going to cost, or forecast outcomes, market forecasts. But ultimately, large groups in real time quickly reach decisions, like a fish school, that rapid and effective, and converge on optimized insights. And so there's a few different architectures that we built. We built a text-based architecture where these groups can hold conversations by text in real time, and I'll show you what that looks like. We've also been building a video-based architectures where the groups get broken up into small video groups. And the cool thing about that, and this is not yet publicly available, is that each group gets an artificial avatar that represents the views in other groups. So it's 6 of us having a conversation by video, and then 1 AI agent. And that AI agent's not making stuff up. It's just expressing insights from other groups, weaving the whole conversation together. And so the first system that uses this conversational swarm intelligence is called ThinkScape, and we built it a couple of years ago. We've been testing it with large organizations, and there's actually some large organizations already using it, and with universities. And I want to talk about what universities have been testing and the results. And so the first question is, well, does this make groups smarter? That's our goal. And so we did a study with Carnegie Mellon in 2023 where we had groups estimate the number of gumballs in a jar. And this is kind of a classic collective intelligence experiment where you take a group, you ask them as individuals, they're pretty bad, but you take the mean and they're pretty good. And so we replicated that with 4 different cases. We looked at the average individual, making an estimate. We used ChatGPT 4, and this is a year ago, so this was not the latest ChatGPT. And everybody was just looking at a photograph of this jar. And ChatGPT 4 was looking at the photograph and made an estimate. We looked at wisdom of crowd, and we looked at conversational swarm intelligence. So the average individual had a 55% error in estimating the gumballs. It's hard. ChatGPT 4 had a 42% error in estimating the gumballs, which really surprised me. It surprised everybody in the project because it was already better than the average human. And again, this was over a year ago, so it might be even better today. And so, yes, super intelligent AI systems are coming. Then we looked at wisdom of crowd, where we took the mean, and we got the error came down to 25%. So it took the crown back for humans. Okay, so a crowd of humans was smarter than ChatGPT, but then we looked at conversational swarm, where the group made the estimate by conversationally deliberating as 250 people, so they were broken up into 50 little conversations all woven together, and it brought the error down to 12%, cut it in half again. And it is a published paper on our website, unanimous.ai, if you're curious. But again, it shows that this path is significantly better than just aggregating data when you can connect groups together. So this worked so well that we did another study with Carnegie Mellon. We said, hey, let's give IQ tests to people as a conversational swarm. Let's see what will happen. And we used what's called a Raven's matrix IQ test, a standard test. And we looked at 3 cases, average individual, wisdom of crowd, and conversational swarms. We did not ask ChatGPT because we figured it actually probably had the answers in its knowledge base. So people wouldn't really trust whatever it did. The average individual scored 100 on the IQ test, because that's how IQ tests are designed. The average person should score 100. When you take 35 people and you have them essentially vote on the answer, it does amplify intelligence, amplified their IQ to 115, got them up to the 81st percentile. But when we had the same, when we had groups of 35 people deliberate together, broken up into 7 little groups that are all connected together, it boosted their IQ to 128, to the 97th percentile. And the individuals had the same amount of time in all 3 cases. They didn't get more time. But the really amazing thing that surprises us the most is in each of these groups of 35 people, consistently, the swarm intelligence outperformed the smartest person in every one of those groups. So no individual in a group outperformed these superintelligence. This is really the first hint of a superintelligence that can outperform every individual. And so again, this is a published paper. You can find it on our website. Okay, and then we asked this other question, saying, what if the human participants could also get information from the AI agents? So right now, the AI agents are just passing insights around. But what if we created another type of agent we call an infobot, that can bring information, just factual information, into each of these groups and do it in a way where each group gets its own little infobot. It's part of the conversation. So they're having a conversation of 5 people, and anyone in that group could ask the infobot a question, and it would answer just factually. But they all see the answer, and every other group gets a different infobot that they could ask different questions to. Would that make the group smarter? Would they work better? And so we did an experiment with Carnegie Mellon to test this around fantasy baseball. And so we said, let's bring together groups of 30 people to have real-time conversations in ThinkScape to draft a fantasy baseball team for the DraftKings daily contest. And if you're not familiar with fantasy baseball, it's a good emulation of a business decision because you get a budget and you have to buy players, and each player has a different cost and different statistics. And you have to buy a set of players, and you have to have a strategy, and it's hard, and then you get an actual result, so we can score it. And so to do this, we created a baseball infobot, an infobot that goes into each of these rooms that knows everything there is to know about baseball. You could say, it has all baseball statistics, and you could ask it, which player had better hitting last year, this player or that player, and it will just answer to the group. But again, all the groups are asking different questions to their own infobots as they're negotiating, and then and so it looks like this. So we have every one of these groups has its own little baseball infobot, and we looked at the average individual, we looked at the wisdom of crowd, and we looked at conversational swarms, and in all cases they had the same amount of time. And also the individuals who were working on their own, they also had access to the internet. So they could ask ChatGPT, or they could ask, they could look up data. So they also had access to basically information. So the average individual scored 47 points on these daily contests. We did this every week for 10 consecutive weeks, and the paper's on our website. It was the 50th percentile. The wisdom of crowd scored 44 points. It was worse. So this is a good example that, like, wisdom of crowd, aggregating data, it really only works for very specific types of problems where you just have a numerical estimate. Here, you require a strategy, right? Each person has a budget. They're deciding, oh, I'm going to spend most of my budget on a pitcher and a couple of hitters, or you could have a different strategy. And so if you're just aggregating the answers across people, you're not capturing people's strategy. But when you allow groups to deliberate, and now information is propagating, you're capturing more than just data. You're capturing the reasons behind their thought process. And so when we brought them together, they scored 62 points on this study, up to the 73rd percentile. So they outperformed 73% of individuals, so it amplified in intelligence. But more than that, for us, these groups were actually able to work together to field a fantasy baseball team. If you imagine getting 30 people in a room and saying, field a fantasy baseball team together, it would not go efficiently, but this was very fast. They were very quickly could reach a decision. And so again, we use this piece of software called ThinkScape. I'll just show you what it looks like quickly, and then I'll talk about some other things. So we have groups of up to 400 people can come into this platform. As I mentioned, it's text-based, so there could be 400 people. They could either have names or they could be anonymous. For a lot of reasons, sometimes anonymous is really helpful in large organizations. And then there's an area where they can chat, either by text or they can speak in and then just and do text to speech if they're not good at typing. There's a place where there's media that can be shared, data, videos, audio, spreadsheets. And then there's an area where there's this deliberation visualizer so that you can, the people in the room, even though they're in their own little room, they have a sense of the big picture. And then a question can appear. And the question can be anything, and I'll talk about a couple examples. In this case, I'm going to show a market research example, only because we see a lot of interest in this type of technology from market researchers because they like to bring together groups of people to talk. They call it a focus group, but they don't trust focus groups because you get 8 to 10 people, and it's not statistically significant, and then one loudmouth in the room, and it shifts the whole focus group. But here we could bring 100 people or 200 people or 400 people into and capture their qualitative insights at statistical scale. And so in this case, the question, this was from a large food manufacturer. The question was, which of these snack brands is most associated with novelty and why? And they had a bunch of different salty snacks. Okay, so there's 112 people in this room. They're in this group. They're broken up into 23 different rooms. And this is sped up, but from the bird's eye view, it's a crazy amount of information going by, right? Nobody would watch the bird's eye view, but you can click on any one of these little rooms. We call them think tanks. And then it's inside that think tank is a manageable conversation. The people are having a conversation. The AI is bringing information into that conversation. And so you could watch any one of these rooms. That's also, that's useful after the fact, but it's not that useful in real time. And so we have this insights view, where in real time, you can watch in real time this 100 people or 200 people holding a conversation. You can see the sentiments of, for different, in this case, salty snacks, rising and falling. It's extracting out key verbatims, insights that are influential in each of these different rooms. And then there's other pages of this where it shows the statistical significance of information as it passes. But the key thing here is that because we have an AI agent in all these rooms, we could be analyzing the entire conversation in real time, extracting assertions, basically answers, ideas, reasons, and then all of the pros and cons being expressed and how people, and again, people are not just giving answers, they're behaving. And so like when they get together this way, like people will argue. Like that's great, we want people to argue. That's showing us their behavior. It's showing us the strength of their conviction and confidence, which is really why these deliberations work. And then because we analyze it in real time, at the end of that, we generate a very quick summary of what these 100 people just thought of. And so that was just a 5-minute deliberation. It was processed in real time, and at the end, this is what comes out.
I am Una, a collective intelligence created in ThinkScape by connecting 112 consumers in AI-powered deliberation. Our collective perspective is that Cheetos is the brand most associated with novelty. That's because it offers a variety of bold flavors, has unique advertising, and offers experimental options that represent adventure. We also find Cheetos to be a reliable pick-me-up and a nostalgic brand. For more details, please see the full written report generated by ThinkScape.
And so as Una mentioned, there's a full written report that gets automatically generated because we've extracted all of this knowledge in real time, and we can automatically put it into a report. And so here's a report. This is a different question. This was a question that was done for the Department of Energy. Should the U.S. build new nuclear power plants? And we brought in 111 people, and these were members of the public, and the idea was to extract insights of what are the fears that people have, what are the positives people see, and it automatically generates this report that extracts all of the ideas that come out. It does a statistical analysis of which ideas have the most sentiment. It looks at which statements made by people were the most influential, had the most sway to drive, because as information propagates, you can see, oh, this comment had a lot of sway. It spread around the system, whereas other comments didn't. And then it will summarize all of the different arguments. Toxic waste. What were people afraid of with respect to toxic waste? Why were people not afraid? So 112 people, which is essentially the equivalent of 10 focus groups, and then it generates a report, and the whole thing's done in an hour instead of it taking 2 months to do. And so it's really powerful, but more importantly, because it's real time, we can use it to build a collective superintelligence. So if we go back to this architecture, now we have this human database, and we have a way to actually harness that human database. We can connect a large group. It could be an entire organization. It could be a division. It could be a group of consumers or voters. And these individuals are going to have, they're not just reduced to data points. They're going to have thoughtful, interactive discussions, being data processors. They're going to react to things. They're going to consider things. Individuals can share their knowledge and expertise and insights, which spread around the network, which is really interesting and useful. And then groups can brainstorm together, so they can build on the ideas of others. They can debate and argue with each other, which is really useful. We can bring an infobot into the system that can bring factual information in. And of course, we're still keeping the human values and morals and ethics and sensibilities as part of the system, which if you're going to make decisions is probably the most important part. And then we get these really interesting use cases that people are already using this technology for. Market research and consumer insights, lots of really interesting things being done. For product development, product planning, large product teams or manufacturing teams working together to capture insights or to make forecasts together. How long is something going to take? How much is it going to cost? In 10 minutes, they can make a collective forecast. Strategic planning and prioritization across organizations. Forecasting, sales forecasting, financial forecasting, market forecasting. We see groups doing inventory forecasting. Employee engagement, so just when you want to engage, get input from an entire organization. Very often it's done with surveys right now. It turns out surveys are counterproductive. They actually make people resentful if they're your employees. When you bring them together in this conversational swarm, they actually have a very positive experience, and they have more buy-in to what the result is. Even if they don't agree with the result, they were part of the deliberation, and they understand the result. And then bringing subject matter experts together. And we have projects with Department of Energy, U.S. Air Force, looking at bringing large groups of experts to solve problems. And then future use cases, we're really interested in large science and engineering projects, like things on the scale of Apollo mission, where you have thousands and thousands of engineers trying to solve hard problems. We can bring them together. And then large-scale civic engagement. You want to understand what your constituents think. You can give them a poll or a survey. Much more valuable to bring them together and have them deliberate and capture their true knowledge and wisdom and insight and intuition. And I was going to close with one last example. It's fun because we just did it last week. So we were asked by a market researcher to predict, will this Paul versus Tyson fight that was on Netflix be one of the most watched boxing matches in history? And there were really strong arguments for and against. And so what we did was we brought together into ThinkScape 107 sports fans, just randomly selected. We had them deliberate conversationally for 8 minutes, and this is what they said.
I am Una, a collective intelligence created in ThinkScape by connecting 107 randomly selected members of the public in real-time AI-powered deliberation. Together, we discussed whether the Paul versus Tyson fight will be one of the most watched boxing matches in history. Ultimately, our collective perspective strongly supports that this boxing match will achieve record viewership due to Mike Tyson's overwhelming popularity, interest in Jake Paul as a controversial figure, the ease of access on Netflix, and the unique generational span of viewers with older generations following Tyson and younger generations following Paul. We also identified an overwhelming desire among the public to see Jake Paul lose this fight, ideally in a knockout. We then made a probabilistic forecast using ThinkScape's unique graphical swarm feature and converged on a 70% probability that live viewership will exceed 25 million. This would make the fight the most watched streamed sporting event in history.
So was it a good forecast? It turns out it was a good forecast, although people didn't get to see Tyson win. But it was a good forecast. There's different estimates. The promoters say there was over 100 million viewers. Netflix only says over 60 million viewers. Either way, it was the most watched sporting event on streaming by a factor of 3 or factor of 4. It even crashed Netflix for people because it was so overwhelming. So that's an interesting example. But again, this was 107 people who came together for 8 minutes and generated that amount of knowledge and insight. That was all captured and databased and reports generated. So that's collective superintelligence. I'm Louis Rosenberg. Anybody who has interest in this or questions, feel free. You can email me or contact us. And thanks.